Hello, ladies and gentlemen. We're going to do 8.4a today. We're going to be doing trig substitution. So we're going to use trig substitution to solve an integral. And then our goal when we use trig substitution is to eliminate the radical under the integrand. So before we get started, let's remember a couple of trig identities. Just a couple, so not to get too worried. All right, the first one is that the cosine squared of theta is 1 minus sine squared theta. So I just rearranged that identity. The next one would be sine squared theta is 1 minus cosine squared theta. And then if I have secant squared theta, this is 1 plus tangent squared theta. And then tangent squared theta is secant squared theta minus 1. All right, so nothing too earth-shaking. All righty, so as we get started for trig substitution, there's a couple of rules that we need to remember. All right, so we need to know that a is going to be greater than 0, and these are going to be trig substitution for integrals, just in case you forgot that little detail. Sorry. So the first one says if I have a squared minus u squared, and we've already done some trig substitution in the earlier parts of the year, but on this one I'm going to let u equal a sine theta, okay? And then I'm going to draw my handy-dandy little triangle. So if I solve for the sine of theta, I would get u over a. And then I'm going to draw the little right triangle that would be associated with that. So if this is theta and sine is y over r, and then I would do my Pythagorean theorem, and I would find that the x distance is going to be a squared minus u squared. So for a squared minus u squared, I'm going to let a squared minus u squared equal a cosine theta. Alrighty. I think that's all of that. These particular types of problems do have restricted domains, and the domains are restricted to this part right here. So if you'll remember, arc cosine, arc sine is limited to the first and fourth quadrants. So in this particular solution, our answer would also be limited to the first and fourth quadrants. The second rule is going to be a squared plus u squared. Sorry, and we're going to let u equal a tangent theta, so that if I solved, I would get the tangent of theta is u divided by a. And again, I'm going to draw my little right triangle. Here's my theta. So tangent is y over x, and then my hypotenuse would be a squared plus u squared. So again, these are just tricks to remember what different trig ratio you're going to use. And then in this particular situation, when I do a squared plus u squared, this is going to end up equaling a secant theta. And I think we'll understand this portion and this portion once we start doing some examples. Okay. And then, what's my next one? One more. 3, I'm going to have u squared minus a squared. And notice that the third one is the exact opposite of the first one. So then I'm going to let u equal a secant theta. And then if I draw my right triangle again, here's my theta. Then, I didn't draw my triangle. Oh well, I'll do it now. So then my secant of theta is going to equal u over a. And remember that secant is the reciprocal of cosine. So cosine would be a over u, okay? And then this side over here is going to be u squared minus a squared. And that would be my y side. This one has two possibilities. So then the u squared minus a squared is going to equal either a tangent theta if u is greater than a, and this would be in quadrant 1, and then it's going to be a negative a tangent theta if u is less than a negative a, and this one's going to be in the second quadrant. Because remember, secant is a restricted domain, just like cosine does, since it's a reciprocal of cosine. Alrighty, I have 3 examples for us to work through. So let's start the first one. And this one is going to be an example of u is equal to, it'd be nice if you could see it, there we go, a sine theta. Alright, so in this particular problem, we want to find the integral of dx over x squared times the square root of 9 minus x squared. If you'll notice, I can't do straight u substitution, because if I let u equal the inside part, then when my du would be a negative 2x, that doesn't equal that, and then it just gets creepy. So, notice that this is my a, and this is my u. U represents the variable, a represents the constant. So in this particular case, because I have a squared minus u squared, just to write that down so we can see it, then that means that my x is going to equal 3 sine theta, okay? And then that means if I solve for sine, the sine of theta is going to be x over 3. And if I draw my right triangle that goes with this, okay, so the sine is y over the hypotenuse, and then this is going to be the 9 minus x squared. Alrighty, so now I'm going to continue with what I let x equal. So if x is 3 sine theta, then dx is equal to 3 cosine theta d theta. Okay, so now I'm going to take this information and I'm going to substitute it into our integral. So I'm going to have the integral of dx. My x squared is going to be, where'd it go? Oops, sorry, I forgot to substitute him. This is going to be 3 cosine theta d theta. That's my dx. And then in the denominator, I'm going to have an x squared, so I'm going to have 3 sine theta, quantity squared, times the square root of 9 minus, and then my 3 sine theta, quantity squared. So I just wrote this all out the first time. Next time, I think we'll be able to skip some steps. So then this is the integral of 3 cosine theta d theta over 9 sine squared theta times the square root of 9 minus 9 sine squared theta. So if you'll remember work that we've done in the past, and the goal is to get rid of the radical, I'm going to factor on the inside. So now I have the integral of 3 cosine theta d theta over 9 sine squared theta, and then the square root becomes 9 times 1 minus sine squared theta. Well, 1 minus sine squared theta is cosine squared theta. And now if you'll notice, I can take the square root. So I end up with 3 cosine theta d theta over 9 sine squared theta. And then I have the square root of 9, which is 3. And then the square root of cosine squared is cosine theta. Well, that's polite, because now these two guys go away. I can pull the 9th out, the 1/9 out front, and I have 1 over sine squared theta d theta. And 1 over sine squared is going to be 1/9 times the integral of cosecant squared theta d theta. And if you'll notice, the problem started in x's, and now we're working with thetas, so we will eventually have to go back to our x's. All right, the integral of cosecant squared is cotangent of theta, so this is a negative 1/9 because it's a negative cotangent theta. So I have cotangent of theta plus c, and now I'm going to go back and use the little triangle that I drew, because cotangent in terms of theta, I can put it in terms of x. So if you'll remember, cotangent is x over y, so I'm going to have a negative 1/9 times the square root of 9 minus x squared over x. Of course, we can't forget our c. And then we report politely, so I would say the integral of f of x dx is a negative 1/9 times the square root of 9 minus x squared over x. And then there's my plus c. So the first example is done. Alrighty. For our second example, this one is going to be about substituting tangents. So this is going to be about a tangent theta. So we're going to find the integral of dx over the square root of 4x squared plus 1. So in this one, my a is going to equal 1, and my u is going to equal 2x. So if I do, because this is u squared plus a squared, that means that 2x is going to equal tangent theta. And then I can draw my handy-dandy little triangle. Here's theta. Tangent is y over x. And then my hypotenuse becomes 4x squared plus 1. All right, so there's our handy-dandy triangle. This is not necessary, but when you start doing your conversions at the end of the problem to go from thetas back to x's, that makes this very simple. Alrighty, so I'm going to keep working from here. So if I had 2x is equal to the tangent of theta, then x is going to equal 1/2 tangent theta, and dx is going to equal 1/2 secant squared theta d theta. And then that means that my secant of theta, because if the cosine is x over r, then the secant of theta is going to equal the square root of 4x squared plus 1. So now at this point, I'm ready to do my substitutions. So I'm going to have 1 over 4x squared plus 1 dx is going to equal, well, my dx was 1/2, and then I have secant squared theta d theta on the top. And then if secant theta is equal to this, and again, this came from my triangle, then in the bottom, this is the secant of theta, because notice that's where that came from. And then one of those goes away, and it leaves a secant of theta on the top. The half can be pulled out front, so now I have the secant of theta d theta. Well, that's pretty easy. So this is 1/2 the natural log absolute value secant theta plus the tangent of theta plus c. But remember, the problem started in x's, so I need to substitute my x's back in. So then this is 1/2 natural log absolute value. The secant of theta is the square root of 4x squared plus 1. The tangent of theta is y over x, so it's going to be plus 2x absolute value plus c. And then, of course, we have to finish by reporting politely. And so I say the integral of f of x dx is 1/2 the natural log absolute value 4x squared plus 1 plus 2x and then plus c. So these are all indefinite integrals, but I could evaluate a definite integral if I needed to. All right, I have one more example, and then we are done for today. Yeehaw, and then you can go watch the Super Bowl, lucky dogs. All right, so the next one is going to involve rational powers. So we are going to find the integral. I have a dx on the top, and then I have x squared plus 1 to the 3/2. And before I get started, I'm going to rewrite this. So, because remember that the denominator is going to be my square root cubed, so I'm going to rewrite this as the integral of dx over the square root of x squared plus 1 quantity cubed. Alright, so now we're ready to start. Again, notice this is u squared plus a squared, so u is going to equal x, a is going to equal 1. And then I'm going to say, because this is true, you have to remember the things that I showed you at the beginning of the video. Then I'm going to get x is equal to the tangent of theta dx is going to equal secant squared theta d theta. And then I'm going to draw my handy-dandy little triangle right here. There's theta. And then tangent of theta is y over 1. And so then here's my x squared plus 1. So that's handy. And then I know that the secant of theta is going to equal the reciprocal of cosine. So if cosine is 1 over this, then this is secant. So this is going to be x squared plus 1. So now I just have to substitute all my values in. So the integral of dx over the square root of x squared plus 1 cubed is going to become, well, dx is secant squared theta, d theta, and then the square root of x squared plus 1 is the secant of theta cubed. Well, then this leaves 1 secant theta in the denominator. Well, the reciprocal of secant is cosine, so this becomes the integral of cosine theta d theta, which is just the sine of theta plus c. Remember, I have to convert from thetas back to x's, so I'm going to do my sine, which is a piece of cake. So then my integral is going to equal sine is y over r, x squared plus 1 plus c, and then I'm going to write the integral of f of x dx is equal to. And you're all done. Alrighty, that's it for today. I will see you tomorrow. Enjoy your Super Bowl.